Good day, everyone! In this video, we'll go through the process of solving the mean and the variance of the sampling distribution of the sample means.
But first, we'll show you the random selected individuals that we've interviewed, that each of whom has a different body weight. Good day. May I know your name and age?
Yes, my name is Genesis Tracy Pakibar and my age is 12 years old.
Okay, so what is your weight?
30 kilograms.
Okay, thank you. Good day. Please introduce yourself.
I am AJ Alcabao, 15 years old.
Okay, so what is your weight?
My weight is 47 kilograms.
Thank you. Good day. May I know your name and age?
I'm Cormisi Paciente. I'm 39 years old.
So, what is your weight?
I'm 58 kilos.
Thank you. Okay, please introduce yourself.
Good day, I'm Kiamay Servas, 15 years old.
Okay, so what is your weight?
My weight is 60 kilograms.
Thank you. So here are the list of the weights of each of the individuals we spoke with. We will consider this data as the elements of the population. So the population is consist of 30, 47, 58, and 60. Now we will solve for the mean and variance of the sampling distribution of the sample means. To do this, I will be referring to these following steps. Step 1. Compute the mean of the population. Step 2. Compute the variance of the population. Step 3. Determine the number of possible samples of size n is equals to 2. Step 4. List all possible samples and their corresponding means. Step 5. Construct and sampling distribution of the sample means. Step 6. Compute the mean of the sampling distribution of the sample means. Step 7. Compute the variance of the sampling distribution of the sample means.
Now let's proceed to the first step, which is to compute the mean of the population. To do this, we are going to refer to this formula. Mean is equals to the summation of x divided by n, where x is the data and n is the number of elements. So our x will be 30, 47, 58, and 60, and our n will be 4 since we have a total of 4 datas. Now to compute the mean of the population, we are going to add all the data and then divide it by 4. So 30 plus 47 plus 58 plus 60 is equals to 195 divided by 4 equals to 49. So the mean of the population is 49. Next, we will proceed to the second step, which is to compute the variance of the population. We created a table with 3 columns, the first of which contains the elements of the population represented by x. The second column contains the difference between the population elements and the population mean, which is 49, which we calculated earlier in the first step. And the third column contains the squared of the second column's results. So the first column has the population elements 30, 47, 58, and 60. As previously stated, the second column will contain the difference between the elements of the population and the population mean, which again is 49. So 30 minus 49 equals to negative 19. 47 minus 49 equals to negative 2. 58 minus 49 equals to 9. 60 minus 49 equals to 11. In the third column, we'll square each of the numbers from column 2. So negative 19 squared equals 361. Negative 2 squared equals to 4. 9 squared equals to 81. 11 squared equals to 121. Subsequently, we will now add the numbers obtained in the third column. So 361 plus 4 plus 81 plus 121 equals 567. Since we now have the value of this, we will now solve for the variance of the population. The formula for the variance of the population is sigma squared equals summation of x minus population mean squared divided by n. We will just simply substitute this to have the answer. So we have 567 from the summation earlier and 4 from the number of elements dividing this. We have 141.75. So, the variance of the population is 141.75.
Now, let's proceed to the third step, which is to determine the number of possible samples of size n equals 2. We are just going to use this formula. So, here the population size is n equals 4 and sample size n equals 2. So, there are 6 possible samples of size 2 that can be drawn.
Now, let's proceed to the fourth step, which is to list all possible samples and their corresponding means. We have created a table with 2 columns. The first column contains the possible samples, and the second column contains its corresponding means. Based on the third step, we will only have 6 possible size 2 samples. So here it is. 47, 60, which have a corresponding mean of 53.5. 47, 58, which have a corresponding mean of 52.5. 47, 30, which have a corresponding mean of 38.5. 60, 58, which have a corresponding mean of 59. 60, 30, which have a corresponding mean of 45. 58, 30, which have a corresponding mean of 44. So this is the list of all possible samples of size 2 and its corresponding means.
Fifth step, construct the sampling distribution of the sample means. We made a table with 3 columns. The first column contains the sample mean. The second column contains the frequency. And the third column contains the probability. In the first column, we have 38.5, 44, 45, 52.5, 53.5, and 59, which were the corresponding means we have computed earlier. Since the sample means 38.5, 44, 45, 52.5, 53.5, and 59 only occurred once, the frequency of the sample means is 1. In the third column, the probability of all the sample means is 1/6. When we add up all of the values in the second column, we get a total of 6. When we add all of the values in the third column, we get a total of 1.00.
Step 6. Compute the mean of the sampling distribution of the sample means. Again, we have created a table with 3 columns. The first column contains the sample means. The second column contains the probability. And the third column contains the product of the sample mean and the probability. Multiplying the sample mean 38.5 by the probability 1/6 is equal to 6.417. Multiplying the sample mean 44 by the probability of 1/6 is equal to 7.33. Multiplying the sample mean 45 by the probability of 1/6 is equal to 7.5. Multiplying the sample mean 52.5 by the probability of 1/6 is equal to 8.75. Multiplying the sample mean 53.5 by the probability of 1/6 is equal to 8.917. Multiplying the sample mean 59 by the probability of 1/6 is equal to 9.833. We then add the results after multiplying the sample means by its corresponding probability. So, when we combine all of the values in the second column, we get a total of 1. And when we sum together all of the values in the third column, we get 48.747 or 49. So the mean of the sampling distribution of the mean is 49.
So let's proceed to the last step. Compute the variance of the sampling distribution of the sample means. So here we have a table with 5 columns. The first column contains the sample means. The second column contains the corresponding probability. The third column contains the difference between the population mean and the sample mean. The fourth column contains the square difference. The fifth column contains the product between the corresponding probability and the results in the fourth column. In the first and second columns, we just copy the sample means and probabilities from previously. For the third column, simply subtract the population mean from each sample mean. So we have a population mean of 49, which we calculated in the previous step. So 38.5 minus 49, we have negative 10.5. 44 minus 49 equals negative 5. 45 minus 49 equals negative 4. 52.5 minus 49 equals 3.5. 53.5 minus 49 equals 4.5. 59 minus 49 equals 10. For the fourth column, we will simply square the answers from the third column. So negative 10.5 squared equals 110.25. Negative 5 squared equals 25. Negative 4 squared equals 16. 3.5 squared equals 12.25. 4.5 squared equals 20.25. 10 squared equals 100. For the fifth column, we will multiply the fourth column's results by its corresponding probability from the second column. So 1/6 times 110.25 equals 18.375. 1/6 times 25 equals 4.167. 1/6 times 16 equals 2.667. 1/6 times 12.25 equals 2.42. 1/6 times 20.25 equals 3.375. 1/6 times 100 equals 16.667. When we add all of the total values in the second column, we get a total of 1. And when we sum together all of the values in the fifth column, we get 47.29. Therefore, the variance of the sampling distribution is 47.29.